The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
This is problem 6. Problem 6 states, to measure moderately low pressures, oil with a density of 8.5 times 10 to the second kilograms per meter cubed is used in place of mercury in a barometer. A pressure change of 10 or 1.0 pascals produces a change in the height of the oil column of about what? So, we're looking for H is equal to what? I always write what you want to look for. And we have, these are what we know. We know that the density of oil is that. Now, I don't know if you know this or if you like this. I always, instead of writing the times 10 to the whatever, I find that confusing because I see that 0 and I see that 2, whatever. It just makes it easier, in my opinion, if you see 8.5, then you have this little e to the 2, and it means the same thing. And that's how you have to write it in, and Wiley plus, that's how calculators write it. And that makes it easy for me because I know then, oh wait, I bring over the decimal point 2 places. Just as a side note. So, and we also know that the change of pressure is 1 pascal. So what you want to do is you start out with, you have pressure is equal to the original pressure plus rho GH. The pressure, this is P naught. So this equation is basically saying if you have something in water here and then you bring it all the way down to here, this is P naught at pressure whatever, and say you're trying to find it here, so that's the pressure difference. Just as a side note of reading the equation. Now, we know that delta P, the change in pressure, is equal to 1 pascal. So, if we bring pressure naught over, we get P minus P naught, which is equal to delta P, which then, because we know that to be equal to delta P, which then is equal to rho GH. Rho of the oil, not of water. Rho of the oil. So, now, we have 1 pascal, we have rho of oil, we know what G is, because we're on Earth, so it's 9.8 meters per second squared, and we're looking for H. It's kind of it's a plug and chug equation from here. So what you do is we have 1 pascal is equal to the rho of oil, 8.5 e to 2 times 9.8 meters per second squared times H, right? So, that's how we do that from here. And, so to find H, all we gotta do is divide 1 by both of these. H is equal to 1.2 e to the negative 4th meters. Very small distance, but measurable. Alright?
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.